Hello, Wyatt. This is going to be just a very super quick review of what we talked about yesterday. So this first one is called the exterior angle theorem. And so the algebraic expression that we can set up is that 120 is equal to 2x plus 4x. So 120 equals 6x, divide by 6, and we get x to be 20. All right, the next figure that we have is that these two base angles are congruent. Because the base angles are congruent, that makes the sides congruent. So we can set up 2x minus 6 equals, and it would be x would be 14 or 18. And it has to be the opposite sides. So we're going to use the 18. All right, let's add 6. So what do we get? 24. And x would be 12. All right, then we went on and we talked about some proofs. So we're given these two triangles and we're given some given information, and we want to prove that AE is congruent to CD. So I'd like to start with the blank diagram. And the first thing given is that EB is congruent to BC. So this segment is congruent to that segment. Then they tell us B is the midpoint. And what does it mean that B is the midpoint here? Well, AB is going to have to be congruent to BD. And the reason is definition of midpoint. Now, is there something else that this diagram is just telling us to be able to use? So we just got these congruent. And then we have this angle in here and this angle in here. So angle ABE is congruent to angle CBD, and that is called vertical angles. Now I can get those two triangles congruent. So triangle ABE is going to be congruent to triangle DBC, and make sure you get your letters in order. We have a side, then an angle, and then a side. So it's going to be side, angle, side. And now that we have two triangles congruent, we can now get that AE is going to be congruent to CD by CPCTC. All right. Then the other things we talked about here is once we started talking about midpoint, we talked about TJ is an angle bisector. Well, there's only one angle that it's bisecting, and that's this angle right here. So what can we conclude? Angle OTJ is congruent to angle JTK. Why can we say that? Definition of angle bisector. Okay, along the same lines, now AW is a segment bisector. So what does that mean? It means that MW is going to be congruent to WN. And why can we say that? Definition of segment bisector. All right, I have another proof here. All right, so what do we have here in our given? MA and HT, so MA, HT, MH, and AT. All right, what else is this diagram telling us? So those vertical angles were kind of a hidden thing. And then another thing that they say is MT congruent to MT, and that's called the reflexive property. Okay, so now this segment's congruent to itself. So now we can get the triangle MHT congruent to, so MHT to triangle TAM, and that would be by side, side, side. Okay, a couple other things that we have to pay attention to in proofs is that sometimes they tell us these lines are parallel, or lines are parallel. So we have to remember the things that we learned about alternate interior. So like 2 and 6, and 8 and 5. Or alternate exterior angles are congruent would be something like 3 and 7 and 1 and 4. Corresponding angles. Now there's a lot of corresponding. Let's just pick 8 and 3 because according to the lines, 8 and 3 are both below. And then according to the transversal, they are both to the left. So they have to be in the same place, exact same place. Consecutive interior are 8 and 2. Now, if you wanted to say 8 and 6 because they're right next to each other, those are a linear pair. Okay, and then we have our vertical angles, which are 7 and 8. And I think you got those pretty darn good. All right, so that's a quick recap of what we did. So I hope this helps. Have a good day.